Let's consider for a moment a graph of y equals sine x. Notice that if we were to sketch in some tangent lines at various points, so here's roughly the tangent line at 0, at pi halves, at pi, at 3 pi halves, and at 2 pi. We could say something like the slope here of this tangent line, m equals 1. Here the slope is 0. Here the slope appears to be about -1. Here the slope is 0. And here the slope appears to be +1 again. Well, if we were to plot those points, that is, at every given x value, plot the slopes, that means that at 0, we would have a point at 1. At pi halves, we would have a point at 0. At pi, we would have a point at -1. At 3 pi halves, we would have a point at 0. And at 2 pi, we'd have a point back at 1. Notice that if we were to connect these points, what we have appears to be a cosine graph. In fact, is a cosine graph. So what we've done again is we've taken the slopes of the tangent lines and plotted those points here in red, and the slope of the tangent line is directly related to the derivative of the function, and what we've ended up with is a cosine graph. And this is an informal proof of the fact that the derivative of the sine of x is the cosine of x. And notice that if we do the same thing on our cosine graph, I'll do it in blue, by sketching in roughly tangent lines at the various points. Here they are. And making sense of their slopes. The slopes are 0, -1, 0, +1, and 0. And plotting those points, so at 0, we would have 0. At pi halves, we'll have -1. Back to 0 for pi, up to 1 for 3 pi halves, back to 0 for 2 pi, and sketching that graph, what we've shown is we have a graph that is the opposite of the sine of x. And we've shown at this point, again informally, that the derivative of cosine is negative sine x. So these are just informal proofs for some derivatives that you must have memorized. And those facts are that the derivative of the sine of x is equal to the cosine of x. And the second fact is that the derivative of the cosine of x is equal to negative sine of x. And from these two facts, we can prove what the derivatives of every other trig identity must be, along with, we'll need one other fact, and that's this from basic trig, that the sine squared of x plus the cosine squared of x equals 1. Now I would encourage you to take the time to derive the derivatives of tangent and cosecant and cotangent and secant yourself. Be able to do it. This way, if you ever forget them, you'll always be able to derive them from basic facts. But we'll do that here. We'll prove the other 4. starting from these three facts. So again, to repeat, the three facts you must know are that the derivative of the sine of x is cosine x, the derivative of cosine x is negative sine x, and sine squared x plus cosine squared x equals 1. From here, you could choose to memorize everything else or know how to derive them for when you use them. If y equals the tangent of x, and we wanted to find the derivative of tangent x, and I didn't remember it, what I do know is that tangent of x is equal to the sine of x over the cosine x. See if you can figure out the derivative of tangent from here. So go ahead and pause the video and see if you can do it. Hopefully you were able to do it yourself, but if you couldn't, notice that this requires the quotient rule. So the derivative of this would be the derivative of the numerator, which is cosine x, times the denominator, minus the derivative of the denominator, which is negative sine x, times the numerator. And all of this is over the denominator squared, so cosine squared x. But if we simplify this, the numerator becomes cosine squared x plus sine squared x all over cosine squared x. But cosine squared x plus sine squared x equals 1. And since 1 over cosine x is secant x, then y prime in this case must be secant squared x. So what we've just proven is that the derivative of tangent is equal to secant squared x. And again, you can either choose to memorize this fact or know how to derive it if you need to. And knowing both is beneficial. If you haven't yet, go ahead and do the other three. Let's derive secant of x. So if y equals the secant of x, and I want to find the derivative of this, I do know that secant is equal to 1 over cosine x. And I could use the quotient rule on this. Let's see what happens if we use the chain rule. I'm going to rewrite this as the cosine of x to the negative 1 power. Well, then the derivative of this by the chain rule would be negative 1 times the cosine of x to the negative 2 times the derivative of the inside, which would be negative sine x. And if we clean this up a bit, negative 1 times negative sine would make this sine x over cosine squared x. But this can be cleaned up to be sine of x over cosine x times 1 over cosine x, and the sine of x over the cosine x is tangent x, and 1 over cosine x is secant x. So we've shown that the derivative of secant x equals tangent x times secant x. There's two others we have yet to prove. The first is, what is the derivative of cosecant? Well, cosecant is the same as 1 over sine. And I'll do this like I did secant. I know that this is equivalent to the sine of x to the negative 1. So when I take the derivative by the chain rule, I get negative 1 times the sine of x to the negative 2 times the derivative of the inside, which is cosine x. Cleaning this up, this will become negative cosine x over sine squared x, which can be rewritten as negative cosine x over sine x times 1 over sine x, which simplifies down to negative cotangent x times cosecant x. So we've proven that the derivative of cosecant x must equal negative cotangent x times cosecant x. The last identity to prove is what is the cotangent of x. And again, there's lots of ways to prove these. And your options are, again, to memorize all 6 of these facts or just know 3 of them and be able to derive the rest. I know that cotangent of x is the same as cosine x over sine x. And so we could use the quotient rule here. The derivative would be equal to the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. And when we clean up the numerator, we will have negative sine squared x minus cosine squared x over sine squared x. And if we factor negative 1 out of the numerator, we will have negative 1 times sine squared x plus cosine squared x over sine squared x. But sine squared x plus cosine squared x is 1, so this is negative 1 over sine squared x, which happens to equal negative cosecant squared x. So what we've proven is that the derivative of cotangent x equals negative cosecant x, cosecant squared x. So there are the proofs for the 6 trig identities, and there'll be a part 2 to this video going through some examples.